Dear students, welcome to my YouTube channel PCM Academy, and this is a lecture series of Newton's law for JEE Main Advanced and NEET also. And in the previous classes I have discussed about normal reaction, and in this class I will discuss about tensional force. So now let me first understand what this tensional force actually means, and let me take an example. You have heard about a rope game, okay? So suppose here is one team is in this side, okay? One team is this side and another team is in this side. Here some people are here and some people are here, and they hold a rope like this. Suppose they hold a rope like this. Then if you feel the rope or if you touch the rope, then what you will say? You will say the rope is loose. But according to the rule of this game, now they try to hold this rope as tight as possible. Okay, now the situation or the state of the rope is like this. Now if you touch the rope and you are asked to touch the rope or to feel the rope, then you will say that the rope is tight. Okay, so this tightness, the tightness that you will say in your language, that this tightness in the language of physics is actually called tension. Okay, so when this tightness comes into picture in these ropes, then the tensional force will appear, and this is purely an electromagnetic force. This is because of the fact that when you tight the rope, then what will happen? The molecules within this rope will displace from their equilibrium position, try to displace. What you are actually doing, you want to do actually, you are just want to separate the molecules from their actual equilibrium position. So interatomic force will appear to resist this. So due to this interatomic force, this tensional force actually appears at each and every point. So you can say that this tensional force is basically electromagnetic force. Okay, is basically electromagnetic force. As I have said earlier, that whatever force you can say will fall into any one of the category that I have discussed earlier about the classification of force. So tensional force is basically an electromagnetic force. Now we need to understand actually the direction of this tensional force, because when we want to solve the problems according to Newton's laws, according to the force equation, then what we will face in the problem, that the direction of tensional force. As I have discussed earlier about the direction of normal reaction, in the same way I like to discuss about the direction of tensional force and the various aspects of tensional force that we will face in problem solving time. Okay, so let me understand about the direction of tensional force. Okay, so basically I can understand or make you understand in one line that the tensional force is nothing but it's always act away from the object. Okay, so it's just a one line statement, and there is a deep insight behind it, and all the problems you can solve, or you can at least you can draw the direction of tensional force in the problems if you remember this one sentence, that is tensional force is always away from the object. Okay, so you can understand it by saying this, that tensional force is always away from the object, but of course along the rope, or string, you can say. Okay, for example, if you suppose here is a object like this of mass m, and here is another object of mass m, and they are attached to each other, a rope like this, and if we put a force over here F, then a tensional force is appear over here. Okay, so what will be the direction of the tensional force in this rope? In this rope, the tensional force will be away from the object. So at first you need to decide for which object you want to draw the tensional force. If you want to draw the tensional force for these objects, then from this object along the rope, the away direction, that is outward direction, is in this direction. So it will be in this direction, tensional force. And for this object, the tensional force will be in this direction, because along the rope, you can say along the rope, this is the outward direction from this object, and along the rope this is the outward direction for this object. So tensional force is always outward from the object or away from the object, but of course along the rope, because in this direction there is no meaning of tensional force. So it will be obvious that it will along the rope. Okay, but it is very important that the tensional force will always away from the object or outwards from the object. But if the tensional force will be same at each and every point, it will depend on some factors. Okay, let me understand what will be the actually factors that depends on which depends that the tensional force throughout the rope will be same or the tensional force throughout the rope will be different. Suppose, let me give you another real situation, that if there is a mass pulley system like this, you will encounter many times these types of problems, that here is a mass pulley system and suppose two masses are suspended like this, M1 and M2, and you are asked to find out the tensional force in this rope or on this string. So if you want to draw the tensional force for this object, from this object the away direction, the outward direction is this. Similarly for this object the outward direction is also this. So this will be the tensional force. But the big question is again, these two tensional force are in same magnitude or different? It will depend on some factors. Okay, and for the first thing you can say that if the mass of this string or the mass of this rope is negligible, the mass of this rope is negligible, this is very, you can say very light string or very light rope, then only the tensional force at each and every point will be same. If the mass of this rope or mass of this string is negligible, then only the tensional force throughout the rope will be same at each and every point. But if there is a mass, then at each and every point the tensional force will be different. So the first point you can say about this thing, that tensional force throughout the string, tensional force throughout the string, tensional force throughout the string will be same if the string is massless. If the string is massless, here massless means actually negligible mass. Okay, so this is one criteria for the tensional force throughout the string or throughout the rope will be same. But if there is a mass, if there is definite mass, then the tensional force at each and every point of the string or you can say rope will be different. Okay, so these are two very important things, and I can explain these two things with the help of Newton's second law. Though I am not discussed till now the Newton's second law, but I think you are aware about Newton's second law as you have studied in your earlier class, that force is equals to, actually net force is equals to mass into acceleration. If we use this, then you can understand this sentence, the tensional force throughout the string will be same if the string is massless. And suppose there is a mass of a string, suppose this is a string or this is a rope kind of situation, okay, and there is a mass m. Let me suppose the mass is m, and suppose the tensional force at this point will be T1 and the tensional force at this point will be T2. Okay, suppose that at any, you can find this T at any point. Okay, suppose here is T1, here is T2, so this is a part of a rope, you can say. Okay, you can say that this is a rope and a part of it, okay, a part of it is this. So I can assume that here the tensional force is T1 and here the tensional force is T2. I just assume it. Okay, so now what will be the force equation if T1 is greater than T2? If T1 is greater than T2, then what will be the net force? The net force will be T1 minus T2. Okay, and according to Newton's law, this T1 minus T2 will be mass into acceleration, that is ma. Now you can see that if there is a mass, then T1 and T2 cannot be same. T1 and T2 cannot be. If there is a motion, then acceleration A, is in this direction, so T1 minus T2 is equal to m. But if we put that the mass of this string is 0, so m is equal to 0, then you can say T1 minus T2 is equal to 0, which implies this T1 is equal to T2. So for massless system, you can say for massless string, the tension of different point will be same. T1 is equal to T2. So we will just assume these things, or we will apply these things in many places. Where the string or rope is massless, we will use this conclusion that the tension at each and every point will be same. Okay, so this is the basic fundamental thing. But sometimes we don't want to understand these things in this way, because we need to understand tensional force before discussing the Newton's law. But if I have assumed that you might have studied this F is equal to ma in your previous class, then I can explain this here also, that why at each and every point of a massless string the tensional force is same. You can explain it like this. Okay, and another case, if there is a friction, okay, suppose I have taken this example again. Let me take the example again. Okay, this mass pulley system, let me take the example again, mass pulley system. For this mass pulley system, okay, now suppose the rope is massless, so tension at this point and at this point will be same, but it will also necessary to hold that this surface is frictionless, because if this surface is not frictionless, then a rotation will occur. Here a rotation will occur, and due to this rotational effect, the tensional force will be different. So only the tensional force in these two strings or both sides of the string will be same. Only the surface is so smooth. The surface is so smooth that friction is neglected. Okay, so we need a frictionless surface through which the rope or the string is dragged. So that surface must be frictionless, and as well as at the same time the string should be massless. Then only throughout the string the tensional force will be same, and if there is a surface, then like this mass pulley system, then in both sides the tensional force will be same. This can also be explained by using torque equation. You know tau is equal to I alpha. If you know, this is, I will discuss these things in rotational mechanics, that this is actually the Newton's second law in rotational mechanics. As we have F is equal to mass into acceleration, similarly there is a torque instead of force for rotational effect, and there is I, that is moment of inertia, and there is alpha, which is analogous to linear acceleration. This is angular acceleration. So these are, if you take these are the analogy term. This is the rotational form of force. This is actually a rotational energy of mass, and this is a rotational energy of acceleration. Then for rotational motion, you have Newton's second law like this, tau is equal to I alpha. So in that case, if there is a friction, then what will happen? This pulley will rotate, and if this pulley will rotate, then there will be alpha. And you can say here the net torque will be, if this is T1 and this is T2 and this is R, then here torque will be tau 1 into R, and here torque will be T2 into R. Okay, so in this side it will be T1 into R, and that side it will be T2 into R. So as there is a net force F is equal to T1 minus T2 or T2 minus T1, here is also T1R minus T2R. This is the net torque actually, and this is equal to I alpha. So when alpha is equal to 0, you can say alpha is equal to 0. If alpha is equal to, sorry, if alpha not equal to 0, if I is equal to 0, here you have seen that T1 minus T2 is equal to Ma, and if M is equal to 0, then T1 is equal to T2. Similarly, if I is equal to 0, then the moment of inertia is 0. That means this pulley is massless. If this pulley is also massless or negligibly mass, then I will also be 0. So in that case, T1R is equal to T2R. So T1 is equal to T2. So you can explain these things again like this. So the tensional force will be same, or the tensional force will be different. It will depend on some factors. Okay, so if there is a, let me conclude the whole things about tensional force. Let me conclude the whole things, okay, that you can understand. At first, you have seen that At first you have seen that tensional force is always act away from the object. Why? Can you say why away from the object? Are you understand why it will be away from the object? Because you cannot push a object by rope. You cannot push a object by rope so that the tensional force will be in this direction. What you can do, you can always pull a object by string or rope, so it will always be outwards from the object or away from the object. Okay, so please keep in mind tensional force is always act away from the object. And the very second one is the tensional force on a string. The tensional force on a string or rope at each and every point will be same if and only if the mass of the string will be 0. So if the mass of the string is 0, that is massless, then at each and every point T will be same. Okay, and the third point is very important, that for a mass pulley system like this, okay, for this mass pulley system, if this is T1 and this is T2, this is suppose M1 and this is M2. Okay, so for mass pulley system, T1 is equal to T2 when if pulley is massless, okay, or T1 is equal to T2 if the surface of the pulley is frictionless. Okay, either this or that. T1 will be T2 if pulley is massless, or T1 is equal to T2 if the surface of the pulley is friction. If any one of this condition will hold, then T1 and T2 will be same on both sides, but it will at the same time it should also hold that mass of the string throughout the string, the mass will be 0. So it should be massless, and one thing, it also should be inextensible. Okay, if it is extensible like rubber, you can say, if it is inextensible, then the tensional force will be changed. So initially for any string, if you talk about any string or any rope, the first necessary condition to be tensional force throughout the string same, that it should be massless and it should be inextensible. But when it passes through some pulley like this, then also the tensional force will remain same, only the pulley is massless or the surface is frictionless. Okay, so this is all about tensional force. You have to keep in mind when you are going to solve the problems based on Newton's law, because when you will draw the force diagram or the free body diagram, you need to understand about the direction of tensional force as well as the direction of normal reaction. And the normal reaction I have discussed in the previous class. If you don't see this video, please see this video and then this tensional force. And the next class I will tell you about free body diagram, then I will tell you about the Newton's second law and how to solve problems by using Newton's second law. Okay, so so my duty is not only deliver the lectures, but I have make you so smart that you can apply all these things in problems. Because in competitive exam like JEE Main, NEET, Advanced, you have to apply this concept in problems. So you need to understand this thing. Your approach should be for problem solving approach. Okay, so I will approach the topics. You can understand if you see the videos from the very first one. You can see that my approach is always not to memorize the concept, but to apply these concepts on problems. So why I will teach you these things in this way. Okay, thank you.